today let us see what are the contents involved in your third year curriculum. One of the course designed is DC machines and alternators. So this course code for this particular subject is 15E31T and designed for 4 hours per week. Totally, it works out to be 52 hours. And here in this course, the exam pattern designed is to have 100 marks as an end exam and 25 marks for continuous evaluation. That is for your internal assessment. And for this particular course, we have designed totally 6 units. Units is nothing but the chapters in OBE curriculum. And unit 1 mainly deals with the construction aspects for a DC generator. So totally, there are 3 wings to be studied in this particular course. One is DC generators, DC motors, and we have alternators also. So in that particular DC generator aspects, you have to learn about the various construction details and what is the working principle, what is the rule behind its working. The construction parts, you have to provide some justification for now selected for design of machine. So totally, this particular chapter has 8 hours allocation. Particular contents for this unit 1, there is an 8-hour allocation, and you can expect normally 2.5 questions to 3 questions from your pattern. So totally, the overall weightage for this unit 1 is allotted as 17%. So your question paper, 17% of the marks is from this unit. So totally, it works out to be around 25 marks, 25 to 30 marks. Now, what is the very basic meaning for a DC generator? That you have to understand. In your previous semesters, you have learned what is a machine, what is a generator. The basic meaning says generator is nothing but a machine which takes part in energy conversion process. Electrical energy will be converted into electrical energy. So here, why it is called a machine? Because the internal parts of this particular equipment, you should never call it as an equipment, it is a machine. That is why we call it as a machine, because it has some internal rotating structure which energy conversion process, that is from mechanical energy into electrical energy. From the basic definition, the energy input will be in the form of mechanical and the energy output will be in electrical form. In order to generate electrical energy, we need to connect the generator along with another machine which is called as a prime mover. So there is a coupling between a generator as well as maybe a prime mover. Prime mover may be another motor, or it may be even an IC engine, whatever it is. In the diagram, you have a coupling, common coupling of the shaft between a generator as well as a motor. This is how the assembly looks like. Now, you may ask, what is the generator do, action, and on what principle is taking place? Basically, a generator works on the principle of Faraday's laws of electromagnetic induction. We all know what are the 2 different statements for this law. First law states always, whenever there is a change in flux linking with the conductor, normally EMF will be induced. Where can you find the EMF induction? It is in the conductor part. So, first law always deals when the flux lines are being cut by the conductor, there is an EMF induction. So, second law normally says about the magnitude of such induction. So, the quantity or the amount of induction depends on various factors. The Faraday's second law says the magnitude of EMF induced is directly proportional to the rate of change of flux linkages. That means to say, more amount of flux being cut by the conductor, naturally the magnitude of EMF induced will become more and more. So there is a direct relation between the number of flux lines cut by the conductor and the EMF induction. So this direct relation is stated in your Faraday's second law. So based on this electromagnetic induction principle, the generator works. Rather generator or a dynamo, both one and the same working principle. It is based on Faraday's laws of electromagnetic induction. Here we have a small equation. Always the induced EMF is denoted by a letter E, and number of conductors, if it is single, we represent the value of N is equal to 1, where N defines the number of conductors used during energy production. And d phi by dt, as we all know from the basic principle given for electromagnetic fluxes, and d phi by dt is nothing but the rate of flux linkages with the conductor. d phi by dt, the whole term says it is the flux linkages. So the induced EMF E is given by the formula N d phi by dt as per Faraday's law. So this direct relation between d phi by dt and E is expressed in this way. Here, you may ask me one question: what is the nature of EMF induced? No doubt E is equal to N d phi by dt, but we have different types of induced EMF. Say like we have dynamically induced EMF, we have statically induced EMF, mutual induction, self-induction, right? So among this, how can you say that it is only a dynamically induced EMF induced in the conductor? Because in case of DC generators, you can keep field always stationary, that is the number of poles is always fixed permanently to the structure, we call it as yoke, whereas conductor will be moved along with the armature. So therefore, here in order to produce EMF, the necessary conditions are met with. What are the important necessary conditions for producing dynamically induced EMF? There must be a conductor, there must be a field, and there must be a relative motion between conductor as well as magnetic field. So all the three necessary conditions are arrived here in case of DC generator. So we can say the dynamically induced EMF is the type of induced EMF induced in all DC generators. Whatever may be the capacity, the nature of EMF, we call it as dynamically induced EMF. So now, if you go for marking the direction of induced EMF, there is another rule, we call it as right hand thumb rule. So here, you know, dynamically induced EMF is produced in DC generator. Since the conductor material is closed by itself, we always can expect the flow of current through the conductor. So therefore, whenever the current flows to the conductor, we call it as induced current. The direction of induced EMF as well as direction of induced current, both are same. You can mark it by observing what is called as right hand thumb rule. Now, this is a simple loop generator wherein which you have seen the conductor being rotated in a magnetic field. The magnetic field is produced between two pole pieces of a magnet, and the conductor is of rectangular shape here. Along its axis, you can rotate the conductor. Now, what is the principle happening here? What you can observe? When the conductor is being rotated, it cuts magnetic lines of forces. So, as per Faraday's law, in the conductor, induced EMF will be there, and that we call it as dynamically induced EMF. Now, if you just see how does a simple loop generator works. In the previous diagram, you have seen rectangular coil being rotated on its axis in between the two pole pieces. When the conductor occupies different positions in plane, linkages linking with the conductor keeps changing. Time to time, you keep rotating the conductor. Naturally, what happens? The number of flux lines cut by conductor varies. And now you can see the two sides of the coil. They are moving. The two sides of the coil are being moved, sometimes parallel to the magnetic field and sometimes perpendicular to the magnetic field and sometimes with certain angular displacement. So therefore, I can say the quantity of EMF induced in all the times is not same, because E is directly proportional to d phi by dt. So since there is change in flux every time linking with the conductor, you can't expect the same magnitude of fluxes being induced in the conductor. So we can say when the coil is rotated in one particular direction, the induced EMF magnitude is assigned an equation E is equal to BLV sin theta. So where V defines the flux density, that is you are rotating the coil in a field, that magnetic field flux density is given by capital B, where L is the length of the conductor, rather length of the magnetic field. V is the speed or the direction of rotation is also important for marking the direction of induced current. Therefore, we say instead of speed, we call it as velocity. So V is the velocity with which you are moving the conductor in the magnetic field. Magnitude of induced EMF is generally expressed by the formula E is equal to BLV sin theta. What is the factor sin theta? Theta is the angular displacement axis of the conductor and that of the magnetic field. So that is the plane of magnetic field as well as the plane of the coil. In angle between these two constitute what is called as theta. So phase angle theta. Induced EMF E is given by BLV sin theta. You can analyze working of Faraday's law also here in this equation. It depends on the speed of rotation, rather it is indirectly related with number of flux lines cut by the conductor, and theta is the angular motion or rather the displacement angle between the field as well as the conductor axis. So when the plane of the coil is horizontal, rather it is at the standstill position, when you don't expect any relative motion, there is no EMF induction. So for all reference purposes, you can say the coil can be moved such that when the conductor side do not cut any conductors, there is no EMF induction. When you are keeping the conductor exactly, moving the conductor parallel to the flux lines just sweep the conductor surface, they do not take part in cutting effect, or in other words, there is no change in flux linkages, so there will not be any EMF induction. The sin theta is defining the sine function of variation of the coil, which in turn contribute to the EMF induction. Therefore, you can expect an unidirectional DC current flowing inside the conductor, what we have called as a simple loop conductor. It is having a single term coil with two active conductors. Now, this is the diagrammatic representation how you are keeping your coil initially, and that is the reference position, and how you are moving the coil with relative to the magnetic field. In first position, that is figure A, you can say the coil is having perpendicular axis, or in other words, the field as well as the coil plane are at right angles to each other. So here, when you move the conductor in clockwise direction, the active parts of the coil, here you can say active part, that will be moving parallel to the field. So rather we say no flux lines are cut. Therefore, at position A, there is no EMF induction. Flux lines at position A are not cut by the active part of the conductor. You can ask me a question, what is that active part? Active part is the part of the conductor which actually cut by the flux lines. Whereas The other part behind that, these two parts, they are inactive part. That means they do not take part in electrical EMF induction. So therefore, we have to speak about only the active part and the flux cut by such active parts. And coming to the figure B, you can see the coil is occupying a different position, wherein which the plane of the coil is parallel to the magnetic field. Is it true? So the plane of the coil is always now in position B, it is parallel to the magnetic field. From here, the coil has been moved through an angle of 90 degrees from its position A. You can see position A is vertically straight, coil plane is vertically straight. It is parallel to the y-axis. And in the figure B, it has been tilted through an angle 90 degrees. So now at this position, what happens? The conductor active part, these parts are being cut by the conductor to highest extent. So therefore, at position B, you can expect maximum voltage induced. So theta is 90 degrees. What is sin 90? It is nothing but 1. In the previous equation we have seen, induced EMF is equal to BLV sin theta. Here you have rotated the coil to 90 degrees. So sin 90 is nothing but 1. So BLE is the maximum voltage induced in the coil. That is corresponding to the figure B. So in the figure B, the coil plane is parallel to flux lines. But when it is moved from its original position, that is from position A, maximum flux lines are being cut. Therefore, at position B, that is 90 degree point, maximum voltage is induced, BLV volts. Now coming to position C. Now what happens in position C? Again, the coil is moved further 90 degrees. That is, totally you can expect a shift of 180 degrees from its point A position, that is original position. Now, when the coil is rotated again at 180 degree position, you are moving the conductor no doubt in the field, but number of flux lines cut by such conductor will be totally negligible. So as a result, you can't expect any EMF induction here. Or rather, flux lines during its cut by the conductor during its position B to C is reducing. So as a result, the magnitude of EMF is getting decreased. So in what way it is decreasing? It is again sine function of the angle theta. So where theta is the angular displacement between the coil surface as well as flux lines. So exactly at point C, you can expect no EMF induced effect. So in the first half, you have seen the conductor displacement from 0 to maximum 90 degree. Again from 90 degree position to 180 degree, you have a sine function of EMF induced. Rather, the curve traced you can observe in the waveform. It is called sinusoidal voltage wave. So we have completed only half rotation of the coil. That is, from its original position, you have moved the coil to 180 degrees. So I can expect only first half portion of the waveform. Now, during my other rotation points, that means consider figure D as well as A. Now, in figure D, what is happening here? You have rotated the coil to 270 degrees from its original position A. You can observe there is a displacement, angular displacement here. Even at point D, you can say the maximum voltage is being induced because you are rotating the coil in such a way that the conductor, active part of the conductor is cutting maximum flux lines in the magnetic field, that is between two pole pieces. Therefore, at point D, you have voltage induced. But when you observe the position of the coil at point B as well as at point B, they are exactly opposite. That means at point B, whichever the conductor which is under the influence of north pole will now occupy the position towards south pole. So there is quite difference in the angular displacement here. So therefore, At point D, you can expect negative voltage induction because the direction of EMF induced reverses here at point D in the conductor sides. So therefore, in the graph also, that means in the waveform, we have shown at point D, the voltage induced, no doubt it is maximum value, BLV sin theta, that is sin theta is equal to 90 degree, BLV volts. But at point D, the voltage induced will be negative. Why negative? Because we have not stated in terms of speed, it is the velocity. That means direction of movement also imparts the polarity for the EMF induction. So as a result, at point D, you have a negative maximum voltage induced. Similarly, coming to the position A, same as the original point A. So you have totally completed one complete rotation. In space, we say it is 360 degrees. From point A till the last figure, that is point A, one and the same, you have totally covered 360-degree angular rotation of the coil, which shows one cycle, that is, which shows totally there is one cycle of EMF induced. So from 0 to 180 degree, it is positive half cycle we call, because the magnitude of EMF induced is positive in nature. It's a conventional practice to assign the polarity now. And between 180 to 360 degree rotation of the coil, we have negative voltage induced in the conductor. So that you can observe using a simple loop generator. So in this way, we have considered for explanation purposes only one turn coil. Number of such turns involved in a practical generator having high power ratings. That means in terms of kilowatt power ratings, you can expect more number of conductors. Therefore, E is equal to BLV sin theta is the common EMF induction equation. But it depends on number of turns. So it is E is proportional to N, where N is the total number of conductors involved in the construction. Now, coming to Fleming's right hand rule, or we also call it as a thumb rule. This is used to denote the direction of EMF induced. Maybe it is a simple loop generator or a practical generator. We use this rule for what purpose? In order to mark or denote the direction of EMF induced in the conductor. So this rule says, with a simple diagrammatic representation, we can explain. You can stretch your right hand in three mutual perpendicular direction. The very word mutual says the first finger and the second finger should be 90-degree displacement. Similarly, the forefinger as well as the middle finger should have a displacement of 90 degrees. So that is the very word mutually stretched positions. One finger to other finger, there should be a displacement of 90 degrees. So you can imagine the corner of a building. Here you have a three axis meeting at that point. One axis with other axis, X, Y, Z axes, where X, Y are displaced by 90 degrees. Similarly, Y and Z axis, you have a displacement of 90 degrees. So between any two axes, totally you have 90-degree displacement. That is the very word saying mutually displaced by 90 degrees. So here, stretch your right hand. Why it is called right hand? Because you have to mark the direction using right hand only, not left hand. Left hand is applicable for motors, right hand is applicable for generators. You have to stretch your right hand with three mutual perpendicular direction such that it denotes the direction of motion of the conductor. The conductor in the field, right? So the direction should be assigned by the direction of thumb, pointing direction of the thumb. Similarly, the forefinger direction will be showing the direction of magnetic flux lines. Always, it's a conventional practice that we show the direction of flux lines emerging from north polarity of a magnet towards south polarity. So from north to south, you can mark the direction of flux lines. So if I say my field is from left to right, I should move my right hand in this direction, pointing this forefinger is showing the direction of flux lines from left to right. You keep this parallel to your field. Stretch your 3 fingers in mutual perpendicular direction. Then whatever the direction shown by the middle finger, this denotes the direction of induced EMF. So the figure, it is clear which finger denotes the direction of what parameter, that is depicted here. So in this way, you can say it is outside the board. If I mark a dot here, it represents inside the board direction. If I show it with an arrow or a plus mark, it shows, that means when you stretch your right hand with 3 mutual perpendicular direction for the thumb, middle finger, such that this forefinger should direct the field, and this should be the direction of motion of the conductors in the field between 2 pole pieces, and the direction showed outside denote the direction of induced EMF. That is the right hand thumb rule. So with these basic definitions, now let us pass on to the complicated DC generator construction features, and you may also have to answer for type of generators, on what basis we classify the generators, how they have to be represented in circuit patterns. So first of all, you should know the sketch, how to draw a generator and what are the different parts involved. Similarly, you have to give the justification for the selection of such materials, because we can't select a single material for making every parts of a machine. So part to part, the construction material differs. Therefore, you should know what are the importance of such parts. You have to give justification why we have selected only that particular material, for what do the different parts contribute, what are their functions, that you have to know. Unit. So here, this is a dismantle, rather a cutaway section of a practical DC generator. You can observe the alignment within an enclosure. You have an axis marked here, that is called shaft of the machine. See here, this is the rotating part. We call it as armature. You can also see the winding exposed here, the slots of a machine. And this is what is called as commutator. This is one of the important part in a DC machine. So DC machine consists of different parts, like you have a rotating member called armature, fixed member called magnetic poles, additional and very important part, which is an exclusively dedicated part in the machine, commutator. Without the action of commutator, you cannot generate DC current or DC voltage at all. So therefore, commutator is one of the in a DC generator. Now this is how you have to draw the sketch of a generator. In the previous, you have actually seen the 3D model, okay? DC generator. Here we have the diagrammatic representation of a DC machine. You can see the outer part, we always denote it with what is called as yoke. We call it as yoke. Yoke along with the poles constitute magnetic circuit in the machine. Always even number of poles attached to the yoke using bolt and nut arrangement. That means there is a permanent fixing of poles to the yoke. And you can also see different parts located here. This is the armature, not a solid piece, very similar. Even the poles are not solid pieces. Laminated parts, I'll tell you what are laminations. And this is how you have to draw the sketch of a DC generator. You have to represent the outer yoke. To the yoke, you have to fix different number of poles. Remember, always the number of poles are even in a machine. It is not odd. Never you can expect a machine with 3 poles, 5 poles, 7 poles like this. So there will not be any odd number of poles. Magnetic during this operation, we designers always insist even number of poles for the machine. So that is why if you observe any diagram or a sketch for a generator, it is always with 2 poles or maybe with 4 poles or 8 poles. But however, you cannot proceed with many number of poles like. There is a constraint. What constraints in selecting number of poles? It is the capacity of the machine and design aspects. Machine becomes bulky, rather it becomes heavy weight. So as a result, you cannot expect many number of poles to be fixed. So modification, they are made from magnetic material, but in order to make them magnetized, we have to have coil even provided for the poles, and those coils are wound on specific region on the poles. You can see the rectangular portion on which the coils can be comfortably made to align are called as pole core region, and you can have enameled copper coils or conductors wound on the core region. They are called field coils. So yoke, field poles and field coils are field windings. Similarly, rotating member armature, it is otherwise called armature core, within which you can find another set of windings called armature winding, and a very important part, commutator and brushes. These are the basic parts in a DC generator. So this is how the diagrammatic representation of DC machines in their respective position should be marked. And if you usual part, you can identify this part now. What is this part? It is nothing but an armature core. So you can observe here, it is not a solid piece. It is not a solid cylindrical structure. Of course, it is a cylindrical structure, but not a solid one. We call it is a laminated structure. So here you have laminations of circular cross section with small slots cut with regular intervals. You can observe in this diagram. These are the slots. These are the slots here. And enameled copper conductors are being placed in these slots. And such circular cross sections are riveted together to form a structure like this, and we call this as a rotating member armature. So it is one of the important part in the machine. And you can also say the enameled copper conductors, which are the armature coils. So exclusively there are 2 windings in a DC machine or DC generator. One is the field winding and second one is the armature winding. So you keep observing the pattern, how they are wound, and what is the material. So these are the enameled copper conductors. This is the diagrammatic representation of armature core. Here you cannot expect any coil here. So there is no coil here in this diagram. You can just see how the slots are aligned along, which forms the slot along the axis of the core. And these are the air holes. For ventilation purpose, these are being fabricated during the design. So all such circular cross sections are riveted together to form a circular structure. We call it as armature. Each one of the circle, we call it as a laminated armature part, core, armature core. So this is the slot. You just see a cucumber example. The whole solid cucumber looks like a solid piece. If you cut into sections, each part is called a lamination. Very similar to that, you can have a narration here, right? It is not a solid core, it is rather a laminated core. Why we do laminations? Very important concept is, whenever you operate a machine, definitely there will be power loss, which contribute for internal heating of the parts. So in order to minimize such heating effect, particularly we say The power loss which is taking part in the iron part is the iron loss. In order to minimize iron loss, we do lamination. But there is exclusively two iron losses. One is the hysteresis loss and the other one is the eddy current loss. In order to minimize eddy current loss, which is the major part of power loss, there's the iron loss, we do laminate the machine like this. Now, I think this is clear with the diagrammatic representation. How is the armature core, how it looks like. This is again the slot representing within the armature. This is a wound armature for different purposes. How it looks like. These are the air holes. This is the winding and this is the armature, laminated armature. So what we can highlight is yoke and poles permanently fixed to the yoke as well as the field winding. They contribute to the stationary parts in a machine. They are not moving. They are called stationary parts. And yoke as well as the pole, magnetic circuit. We call it as magnetic circuit in the DC generator. The field winding needs DC winding. Whatever the field winding you give, we call it as DC winding. That is the stationary parts in a machine. And if you take up the assembly of a pole, each pole in a machine is distinctly fixed to the yoke using bolt and nut arrangement and a steel rod. So these are the bolts for fixing permanently to the yoke region. So you can observe these are the riveted holes. Even this pole structure is not a solid one. In order to minimize the eddy current loss, we do laminate. This is the laminated section. Such sections are riveted together to form such a structure. We call it as a pole. And you can see in the design of pole, we have two distinct features. One is a rectangular portion which is called as pole core region. And this is an extended portion which is called as a pole shoe region. Now, the winding, armature winding will be fixed in the pole core region surrounding this core area. You can observe this is the winding, this is the laminate portion of the pole. Winding is located on the pole core region. The stretched portion very close to the armature will be called as pole shoe. Is it clear now? So a laminated pole has pole core region and pole shoe region. Pole shoe region is somewhat stretched and pole core region is almost rectangular in shape. The DC windings or the field windings are otherwise called exciting coils. The other word given for field winding is exciting coil. So exciting coil is wound around the pole. It is placed in the pole core region. So all this we have discussed here. The pole is the stationary part. It is permanently fixed to the yoke using bolt and nut arrangement. It is not a solid piece, rather it is laminated portions. All such laminations are riveted to form such structure. Poles forms the magnetic part of the circuit. The lamination of pole minimizes eddy current loss, which is one of the iron loss, power loss, which takes place in the iron part of the machine. And this contribute for heating effect in the machine parts. Each of these laminations designed for 0.25 mm thickness to maximum of 1 mm. So that is the standard practice or design practice. They uses 0.25 mm to 1 mm thickness lamination for pole lamination. And they are secured permanently to the yoke using bolt and nut arrangement screws. And what is the material involved for making poles? It is cast steel or cast iron. So here, why we do select only cast steel for large capacity machines. Small capacity uses small cast iron, but for normally commercial machines uses cast steel. What is the purpose behind it? You have to give the justification. Cast steel has high permeability. That means it produces maximum fluxes with minimum. So the current or the flux producing capability is more with cast steel. It is light in weight. Annealing of steel, if used for large pole designs, reduces the chance of rusting. So annealing process is something related with the mechanical. It says sudden heating and sudden cooling process. Part you have to preheat once they are fabricated. Select it for heating as well as sudden cooling. It increases the tensile property of the material. Rather, vibration withstand capacity, or in other words we say mechanical strength will be improved. So this is how we have to give justification. So as the cast steel is rust free when it is subjected for annealing processes, it increases mechanical strength or tensile strength. So when such material is being used for securing the post to the yoke, there is no crack developed during vibrations. When they are subjected to severe vibration during machine operation, nothing, no damage will be happen to poles. So therefore, we use cast steel as the material for large capacity. Now, what is the main function of such pole core as well as pole shoe region? Poles, as being the magnetic part of the machine, produces necessary flux with the help of field windings. Pole core region, by its exclusive design, supports exciting coils because coils will not flip away from the positioned position. So it supports exciting coils. As the pole shoe is extended portion, it spreads flux uniformly in the air gap. So this is very much needed. Other can't expect the EMF generation to be symmetrical all over. So throughout the pole region, the flux density must be maintained uniform. So in order to make uniform distribution of the flux under the polar area very close to the armature, we use spread away section of the pole shoes. Pole shoes reduces the reluctance of the magnetic path. So as usual, air gap has high reluctance compared to other magnetic materials. If the air gap is lengthier, very close to the armature, there will be wastage of fluxes. All the flux produced will go away simply without contributing for induction of EMF. In order to avoid such losses of fluxes, we have to provide minimum reluctance path. That is considered by spreading the pole shoe region and making the curved nature for the pole shoes. So that is one of the important criteria why we manufacture poles with exclusively spread away pole shoes. So pole shoes reduces the reluctance of the magnetic path. So this is how you have to use cast steel for making poles, and you can give why there is a exclusively material selection for that particular part, and why we go for lamination and annealing process before the poles are being assembled to the yoke, and what might be the maximum dimensions for each of the lamination. So this is how you have to study about the different pole nature, pole construction, pole working, function of the pole. What do they contribute? So coming to the next part, it is the rotating member, equally important part, without which you can't produce EMF at all. So the other one is armature core. As you have seen in the diagram, it is a cylindrical structure. It's a hollow cylinder built with laminated parts and made from silicon steel discs. The purpose of adding silicon is again to minimize power loss. Here we say hysteresis power loss. When the conductor is moved in the field, naturally it is subjected for direction reversals, regular reversal of the direction. The conductor, once it will be under the influence of North Pole. During next position, it may come under the influence of South Pole. So during continuous rotation of the armature, each conductor will alternately come under North Pole as well as under South Pole. So this magnetic reversals hamper the EMF procedures. So therefore, if you minimize such power loss, which is majorly contributed by such magnetic reversals, we can go for silicon steel made from sheet material or sheet steel discs. So magnetic reversals contribute hysteresis power loss. If the hysteresis power loss is more, it is an iron loss which is taking place in the iron part of the machine. If hysteresis loss is more, which you cannot avoid during magnetic machine operation, definitely you have to go for design modification in which you can losses. So therefore, sheet steel discs are being used for the manufacturing of armature core. And during fabrication, discs are fabricated in order to form a slot. You have seen how the slots looks like in a bare armature core, and air ducts are also punched in order to provide cooling effect, that is natural air cooling effect during machine operation. Up to diameter of 40-inch armature diameter, circular stampings are used within a laminated sheets, but above 40-inch diameter, so sections are cut in circular sections, and each section may have the sector shape, and all such sector shapes are assembled to form a circular section. So within the lamination, you may have some 2 to 3 parts which are sector in shape. So that is why we just see the different designs in the machine armature lamination. What is the material used for making armature core? As we have told, it is silicon steel. The purpose of adding silicon is to minimize hysteresis loss. Hysteresis loss is one of the iron loss, which is taking place in iron part of a machine. So steel provides high mechanical strength. Armature is subjected for continuous rotation throughout machine operation. Naturally, many vibration and stresses will be armature part. So therefore, you have to make armature core very strong. That is why we select silicon steel. We have to minimize iron loss. We have to provide good mechanical strength for the armature. So these two are considered by selecting silicon steel material. That is the exclusive clause why we go for silicon steel material for the design of armature core. As usual, you have seen the windings are provided in the slots. They are aligned in the slots punched in the armature core. Armature windings are normally made from enameled copper. What are enamels? Enamels are, it is an insulated coating provided on some conducting part using some organic based materials. Usually the process of coating involves 0.05 mm thickness made from polyamide or oleoresin. These are the two composite materials which are used exclusively to make an insulation part over the conducting part. So copper will be enameled using polyamide and oleoresin. They are the commercial materials used for providing enameling of copper. So normally coating range is around 0.05 mm, very small thickness. The armature windings forms the electrical circuit in the machine. As you have seen, poles and yoke forms the magnetic circuit. We have electrical circuits also here. The armature forms electrical circuit of the armature winding forms electrical circuit of the generator. but armature core forms magnetic circuit. Armature windings are housed in the armature slots. These slots are provided in the armature core. Armature windings are normally insulated from the slots using leatherite sheets. We cannot keep, though they are enameled copper conductors, we cannot keep them as such in the slots, because armature core, because of the iron losses, is getting heated during machine operation. Damage caused to the insulation of the winding, that is enameling, may go off. So in order to take care of that, we place what are called as slot insulating materials. Normally, commercially used material for providing slot insulation is leatherite sheet. So we commercially call it as leatherite sheets. So leatherite sheets will be used for providing slot insulation. Apart from that, you can go for Manila paper. They call it as Manila paper, trade name. Mica folium. These are the three names of the slot insulating materials. They will be in the form of thin plastic sheets. They are not plastic, they are resin, composite resins. Or impregnated also be used portion of the coil in order to insulate the coil from the slots. Why leatherite sheets are used, or why slot insulating materials, Manila paper has to be used? High insulating resistance and easily available. They have good dielectric properties, that is insulating properties. Absorb moisture very compared with other insulating materials, and they are easily can be formed into the sheet form. So they are more flexible. You can bend them to any required shape. That is why leatherite sheets are being used for providing slot insulation. I told you, after saying the major parts, that is the poles, pole shoe assembly, and armature, coming to commutator. You have seen what is the very function of commutator. Without this part, you cannot go for DC generation at all. Normally, in the winding, whatever the voltage is induced, it is of AC nature. You have seen sinusoidal nature of the voltage generated. Induced EMF is sine wave. So, in order to make it unidirectional current or unidirectional voltage induction, we need the very commutator in a machine. So, physical connection of armature winding is made to the commutator called as lux. So, end connection of the armature winding will terminate at the commutator part. Again, commutator is not a solid piece. It is made with different segments. 1 to 1, you have a mica insulation separation between commutator segments. The function of commutator in a DC generator is to collect the current generated in the armature winding, that is armature conductors. In case of DC motor, the function of commutator is quite reverse. DC motor, we feed DC energy, that is DC current will be fed. It has to convert it into AC before they are going for winding. Whereas in case of generator, the induced current pattern is AC. To the load circuit, you have to feed DC. That conversion of AC voltage into DC, or to convert AC current into DC, is done by using split rings or commutators. So you can see here the commutator connection of the winding is terminated at commutators. Commutator is not a solid ring. Again, it is made from different segments. This marking indicates separation, insulation separation. We use mica insulation between the commutator bars or commutator segments. The whole structure we call it as commutator. You can also observe the positioning of brushes on the commutators like this. So normally, if P number of poles are present in a machine, there will be P number of brushes. In some machines, you can observe only position of 2 brushes. Whatever may be the number of poles, depending upon the winding connection, we may have only 2 brushes, maximum of 2. In some machines, you may expect number of poles same as number of brushes. But this is not always true. For end connection, that is to tap current to the external load circuit from the brushes, we need only 2 terminals, one positive and one negative. So, in case if there are many brushes in the machine, all similar polarity brushes will be interlinked and it is called as a common positive brush. Similarly, all symmetrical negative terminals, negative potential points of the windings will be grouped together, a single negative brush. So normally we have, or we can expect only 2 brushes in a machine. That is why we always denote 2 brushes on the armature or on the commutator segments, one positive brush and one negative brush. But it may not be true for all cases. So in case of winding pattern, if we say it is wave type, you have only 2 winding sets, 2 brushes. If I say in a machine, you have many number of such parallel paths formed by the windings, then you may go for many number of brushes. The number of brushes may become equal to number of poles. It is true also in a machine. But for final connection, if we have only 2 brushes, it is more than sufficient. So therefore, conventional practice is to have only 2 brushes resting on the commutator segment. And these brushes, where they are mounted or where they are placed in the brush rackers. We call it as rackers. Something is a mechanical assembly racker arrangement within which carbon brush will be placed. So brushes are fixed permanently. When the commutator is rotating, brushes resting off the commutator, there may be wear and tear. So therefore, we always go for carbon brushes. Because one of the main reasons for selecting carbon as the brush material is it has got self-lubricating property. So carbon has self-lubricating property, or in other words, wear and tear during rotation of the commutator is minimized with the selection of carbon material. So therefore, we use carbon brushes. In large capacity machines, instead of carbon, we go for graphite brushes. So because current collection and the resistance offered contact area and conversion process, we call it as commutation process. So all that advanced processes becomes complicated if you simply go for carbon. So if the capacity of the machine is more, you have to go for graphite material. If the capacity of the machine is small, capacity in the sense power rating. So if the machine has to handle lower currents, load currents, then you can go for carbon brushes. This is the another commercially available commutator and winding assembly showing the entire armature along with the commutator. So as we have seen, commutator consists of number of copper segments. And always the number of commutator segments is equal to number of armature coils. You have seen each coil has 2 conductors, active parts I have told, and the end terminals are marked to different segments, not they are connected to same commutator segments. And brushes are usually made from carbon, or for higher capacity machines it is again graphite. And brushes rest in the rackers, brush rackers, which are provided with a pigtail so that you can align the brushes to sit exactly on the commutator, exactly required position. And what material we use for commutators? It is hard drawn copper. It is in the form of segments. And in between commutator segments, you can observe a layer of mica insulation. Why we have to select only copper, not aluminium, for making commutators? The first foremost thing, copper has high thermal conductivity. The heat generated due to frictional effects will be minimized because of high thermal conducting nature of the copper. Less wear and tear. Copper is rust free, right? And it is not brittle like aluminium. Aluminium is light in weight, but it becomes brittle with the increasing temperature. Again, the increases. So if you go for copper, you can avoid this brittling effect. So you cannot expect any cracks to be developed in the part during its operation. Easy to solder. Copper, you can winding end connections can be easily soldered. And copper has the high conductivity compared to other conducting materials. Low resistance of copper. And one of the important property is malleable and ductile. You can draw the copper in the form of wires or in the form of sheets. So the malleability and ductility are the added properties for copper, where we are using it for making commutators. And of course, copper is the non-magnetic material. That is why we have considered copper commutator segment in the design features. Wherever the armature windings are involved, you have to have electrical properties more related rather than for magnetic properties linking. So highly resistant to corrosion. So these are the properties why we have gone for selecting copper as the base material for making commutators in the machine. This is the commutator portion. This is the entire armature. You can see commutator segments here with mica insulation. This is how a wound armature looks like. That means after being the winding placed in the slots and providing all necessary insulations, this is the diagrammatic view how you can expect an armature of a DC generator. And the final part is the bearings. Normally in a machine, it's a mechanical part. Ball bearings are being used. Purpose of using is to minimize the wear and tear of frictional effects, to minimize the friction and to minimize the wear and tear. We always go for bearings. See, out of these topics in the unit 1, you may be asked 3.5 questions. Normally, the question pattern is like this. You may be asked to list different materials used for manufacturing of particular. Maybe name the materials used for making the following parts in a DC generator and justify. This is an application level question. You have to justify, give justification. Justification means why only that particular material is taken for making a particular part. You may be asked to draw a sketch, neat sketch of a generator and label different parts. Or you may be asked, state the working principle of a DC generator, how it works. Write all the necessary parts in a machine and their functionalities, what do they do. And classify the materials or classify the electric circuit as well as magnetic circuit in a machine, DC generator. You may be post a question on such concepts. And if you are asked for 10 marks question, you will have to explain along with the construction, the working procedure and with a neat sketch. Construction means always assembled with a sketch. So if you are asked a question on construction, try to draw a simple sketch and explain different parts, label the parts. So that is how this unit 1 deals with. Thank you.
Thank you, sir. First of all, I would like to thank D.V. Srinivasmurthy, principal. He has introduced such a tremendous teacher to all of us.
Thank you, sir. Thank you, sir.
Yeah, exceptionally good, madam.
Thank you, sir.
Very good. And we have to be very proud that in our department, you like resourceful faculty are available. So through this media, we are very proud to announce that we have got very good faculty. And I think your lecture was such effective, and really we are all electrically charged. And I think all the listeners from all various centers also, they are electrically charged. You are a fit person to be an electrical professor, and we thank you once again. Tremendous and beautiful, very effective lecture. And now I request some of your students, because you have come along with your students. Your students are also available in our studio now. I request some of your students ask some questions. Otherwise,
if you have any doubts about topics what you have already covered, you can post me some questions.
If you don't have any doubt, you can give your feedback also. How was the lecture? What you have understood by the lecture?
Yeah, you can. Come on. You can openly speak. No problem at all. If you have any doubts, no problem. We are all one and the same. You post. I'll try to.
What's the electrical circuit and magnetic circuit? I mean, what's the electrical circuit comprises of and the magnetic circuits are comprises?
Yes. Sit down. The magnetic circuit always in a machine tries to produce necessary flux which is needed for EMF generation. We say EMF is an electrical quantity or a parameter, whereas flux is a magnetic parameter. The components, or rather the parts which contribute for production of magnetic fluxes, they are classified as magnetic parts in a machine. They comprise mainly yoke, field poles, right? And even the air gap, where the availability of flux links, flux will be more. All these contribute for magnetic circuit. They are classified as magnetic circuit in a machine. Whereas armature windings, brushes, commutators, they provide a flow for the current to the load circuit from the winding. So they are considered as electrical circuit, because you can say conductor is the electric part. It's a conducting part which provides a path for current to flow in a machine, right? So all these armature conductors, commutators, brush assembly, along with the load circuit, they constitute electrical circuits of the machine. Is it clear?
Any questions? How effective it was, the lecture? How do you feel? Whether it was very good, you have understood everything, otherwise you are not very clear. Something you have to say now. Yeah. Anybody can tell. You are from the same college, huh? Where is it? Yeah. Just give your feedback. Give your feedback.
It is very effective, ma'am, but still we are expecting more and more such interactions and more such videos from.
Most welcome.
Okay, fine.
Yourself. Yeah, it was nice, huh? Because they have realized already they have finished one lesson. This is fine. It's nice. Thank you, ma'am.
Thank you.
Okay, thank you. Now, Shima, please connect to some other centers. The other center students may ask some questions.
Sure, sir.
Yes, please connect to Chandra. Yes.
Hello. GPD Chandra. Hello. GPD Chandra. Principal. Okay. GPD Karwa.
Yes, sir. Hello.
Hello, sir.
Ma'am, can you hear us? Hello.
Hello. Hello, sir. Please, sir.
Ma'am, I have a question. Hello.
Hello.
Ma'am,
Kelly, question Kelly.
ma'am, when you are connecting armature conductor to the
Huh.
commutator, you told that we are going to solder it.
Yes, we are listening.
Yes, we are listening.
Ma'am, when you are going to solder it, is it withstand high temperature at soldering?
No, soldering is done through lux. It is not directly. The winding terminals are not soldered at the commutator segments directly. Before they are connected to the commutator segments, they are attached to the lux. Lux are some two terminal devices. You can go through your presentation, are the means through which you can again connect it to the commutator segment. Winding terminals are not directly linked to the commutator, rather they are connected through lux.
Okay. Okay, ma'am. Thank you.
Thank you. Yes, anybody? Any questions?
GPT carpet. GPT तुमको GPT तुमको
Hello? Hello? Hello, dear friend? Dear students? Am I audible? Hello? 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 Disturbance.
Hello. GPT तुमको
Hello, I am from KPT Bangalore.
Okay, ಮಾತಾಡಿ ಸರ್.
ತುಂಬಾ ಚೆನ್ನಾಗಿದೆ presentations, very good presentations, madam. Voice also very much
Thank-
clear. Lot of
Thank you, sir.
Our students are happy.
Thank you.
Very much.
Provide them an opportunity to pose some questions.
Madam, what?
Hello sir.
Tell me.
Yes, sir.
Any questions are there?
Any questions, sir, from the student side? Any doubts?
Hello.
Share your ideas.
Students.
Hello?
So that idea. Feedback.
Okay, give the feedback. Hello sir.
Clear it out.
Feedback. That's really helpful.
Hello, ma'am. I'm from KPT Bangalore.
That's really
Hello.
Really, mother.
Hey.
The program was very good, ma'am. I'm Sohan from KPT Bangalore. My friends, I guess all of them have understood everything, whatever you have taught, and they are not having any doubts, I guess. So thank you, ma'am. Thank you for the presentation.
Okay, thank you. Okay, thank you. Father, would you like to give your feedback?
Father, sir.
Father. Yes, please.
Sir, presentation was very good. The audio quality was much better than the previous sessions today. Our students are happy with the presentation. But as this is being the first one, students are a little hesitant to ask questions. Maybe in subsequent sessions, students will come more free openly with the questions.
No hesitation. It is open to students.
So there is knowledge and experience for the students.
Yes, sir. You are there for students.
Thank you, Father.
Thank you, sir. Thank you, sir.
Father, when you are giving your lecture, Father, when you give your lecture?
Just give me 2 days.
After 2 days?
Day after tomorrow.
Okay, thank you. Thank you.
Hello, sir.
So we request all the centers to mute their mic except STP.
Sir.
DVS, come on. Okay, DVS.
Hello, sir.
I'm present, madam.
Okay. All other centers should mute their mic. Okay, DVS, please give your feedback.
Hello, sir.
Hello, can you hear me, madam?
Hello, sir.
Hello.
Hedi, DVS, matadi.
Madam, your presentation was fantastic.
Thank you, sir.
Voice was typical teacher voice. No hurry in your presentation. Wherever pause was required, you are given, and it was very good. And of course, our students are very less in number in the studio. I could see full strength should have been there. Next time we'll do from here. We'll see that all students are there. In the we'll create a classroom environment so that you can interact with the students live here itself. We'll do that. But thanks, madam, for representing SDP principal and doing wonderful work over there.
Thank you, sir. Thank you very much.
DVS, we request you to deputy my madam continuously to our center.
Sir, definitely.
Instead of getting only your students benefiting, let all the students of our state get the benefit.
Definitely, sir. Yesterday in the meeting, I told all faculty members, be prepared. Anytime any call comes from the Honorable DTE, our faculty should go there and give presentation.
Very short notice she has prepared, because in the morning she met me and she was reluctant to give the lecture in the morning. And now she has, with the full preparation, it was so effective.
Yes, sir.
Yes, sir.
Thank you
so much.
We will support, sir. We will support for all.
Thank you so much.
And innovative, sir. Thank you, sir.
Any question from your center, from the students?
No, sir. No students are seated here.
Okay.
I have sent a couple of.
Okay. Thank you so much.
Thank you, sir. Thank you, sir. Thank you.
Thank you for your support. Thank you very much.
Hello.
GPT Gulbarga.
Hello, Karla.
GPT Gulbarga.
ಬನ್ನಿ ಸರ್ ಯಾಕೆ
GPT Gulbarga.
Gulbarga, please come online. Yes, please.
Hello, sir.
Extra, you can speak without external mic also.
Matadi, sir. Your voice is not audible, sir.
You can't hear your voice. You unmute your mic first.
Okay.
Okay, now come on. Here's the Armature.
Hey, sir.
Sir, background disturbance is there. Check ಮಾಡಿ. Mic check ಮಾಡಿ. We are not getting clear voice. Some disturbance is there in mic. Okay, sir. Speak up. Karvara mute ಮಾಡಿ. Karvara mute. Hello, ಮಾತಾಡಿ sir.
ಹಲೋ ಚೆನ್ನಾಗಿತ್ತು ಮೇಡಮ್ ನಮ್ದು.
ಹಲೋ
ಹೇಳಿ sir. GPT Karvara, mute your mic.
Only I finished the topic what you discussed. It was a little bit better session.
ಹಲೋ
Hello, sir.
ಚೆನ್ನಾಗಿತ್ತು ಮೇಡಮ್, ಥ್ಯಾಂಕ್ಸ್.
Thank you, sir.
ಹೆಗ್ಡೆ ಸರ್ ವೇಟ್ ಮಾಡಿ ಸ್ವಲ್ಪ ಹೊತ್ತು.
Now we will back to you.
ಹೆಗ್ಡೆ ಸರ್ ಮೈಕ್ ಮ್ಯೂಟ್ ಮಾಡಿ.
ಹಲೋ
We will back to you.
Gulbarga is online, please. Okay. Headi sir.
Sir, session was wonderful.
Very good, thank you.
It helped our students to know more about construction and
Yes.
parts of the DC generator. Recently, I completed the topic in the class. Aruna madam's experience helped our students to know more about the construction of the DC.
Thank you very much. Is there any question posed from your side from the students?
Any queries from the student side, sir?
Regarding the parts, some DTE function, anyone? Magnetic circuit, electrical circuit, madam, when you were explaining, one of our students, Danny, was asking.
Yes, please.
Armature comprises magnetic circuit or electrical circuit?
Sir, some problem with the mic. We heard only armature and nothing more than this. Anyway, there is a disturbance in the line. Thank you. Anyway, thank you. Thank you, sir. We will make such an arrangement next time. 1 minute, we will make such an arrangement next time. If such questions can be typed and posted, then it will be easy to answer. Sometimes there will be a voice disturbance. Yes. Now also you can type the question and post it, we will answer.
Okay, sir. Thank you. Thank you.
Thank you. Thank you very much. We will go to Karwar now. Hegde.
Type your question in chat window, sir. We will answer.
Yes. Through chat we answer. Okay.
Okay. GPT Karwar.
Yes, Karwar, please. Hegde.
Hegde sir.
ಪ್ರೋಗ್ರಾಮ್ ಚೆನ್ನಾಗಿತ್ತು ಸರ್. ಈಗ ಹಲೋ
ಕೇಳಿಸ್ತಾ ಇದೆ, ಹೇಳಿ.
ಪ್ರೋಗ್ರಾಮ್ ಚೆನ್ನಾಗಿತ್ತು. ಮುಂದೆ ನೆಕ್ಸ್ಟ್ ತಯಾರಿ ಮಾಡ್ಕೋಬೇಕಾಗಿದೆ. ಮುಂದೆ ಪರ್ಮನೆಂಟ್ ಆಗಿ
ನಿಮ್ದೊಂದು ಇಂಥ ಸ್ಟುಡಿಯೋ ಮಾಡ್ಕೊಳ್ಳಿ, ಮತ್ತೆ ಅಲ್ಲಿಂದ ಲೆಕ್ಚರ್ ಕೊಡ್ಲಿಕ್ಕೆ ನೀವು ತಯಾರಾಗ್ರಿ.
ಮಾಡ್ತಾ ಇದೆ ಓಕೆ.
ಹುಡುಗರು ಏನಾದ್ರು ಕೇಳ್ತಾರ, ಪ್ರಶ್ನೆ ಕೇಳ್ತಾರ ಅಲ್ಲಿಂದ?
ಇಲ್ಲ, ಅವ್ರಿಗೆ ಅರ್ಥ ಆಗಿದೆ.
ವೆರಿ ಗುಡ್ ಫೀಡ್ಬ್ಯಾಕ್. ಥ್ಯಾಂಕ್ ಯು ವೆರಿ ಮಚ್ ಹೆಗ್ಡೆ ಅವರೇ. Thank you so much. Any other
GPT Vijaypura.
Now you go to Vijaypur. And you mute your mic.
Hello, sir. GPT Vijaypura.
Okay, sir. Sir.
Very informative.
Mic on ಮಾಡಿ sir. Mic on ಮಾಡ್ಕೊಳ್ಳಿ.
Okay. And the information given was very accurate and more informative. And whatever the students have learned, and they will go through that. And I think you have shared the PPTs also. We will provide the PPTs. I have a suggestion. If this session, if you load on the YouTube, it will be very better for the student to go through this, because all the students are having nowadays smartphones in their hands.
It is available, sir. Yes.
It is available
on the YouTube.
Search for DTE Studio in YouTube.
Live is also available, record is also available.
Sir, the video is lively available. Live is going on.
On YouTube, you are available here, sir. You can see in this. You can see this on the YouTube. It is a live. You have to tell all the students of your institutions and to all the other institution also. Let the students open their YouTube. It is available on live also, and it is available recorded also. And previous 2 days, our lectures were viewed by more than 1,000 students.
DTE Studio channel, sir. Search for DTE Studio channel on YouTube. You can get all the videos that are uploaded in previous days, also including today's video.
Okay, sir. I will carry your message to all the students.
Yes.
Our student has one question, sir.
Yes, please.
He will ask.
This is live.
Sir, what is the difference between copper conductor and hard drawn copper conductor?
Yeah, aluminum. Copper and hard drawn copper, right?
Yes, sir. Yes, madam.
See, usually for conductor materials, say copper. Again, though the cost for copper compared to hard drawn may be less, but some particular required qualities should be incorporated for copper. Improve the malleability nature, ductility nature, and you can improve again the tensile strength whenever you are using it for making parts of a machine. That means laying, contouring, various situations. Hard drawn is increasing the tensile strength again for the copper. It's a mechanical process, not electrical related process. It is a mechanical process which is available in the market as hard drawn copper sheets itself. Hello? Hello? Another student? Yes, come on, please.
What is the function of commutator?
Yes?
Ask once again.
Ask. What is the function of commutator?
Right.
Repeat once again. Repeat the question.
What is the function of commutator, ma'am?
See, I have told commutator collects the current from the armature winding. Winding terminals are connected to commutator segments through lugs. So, the current flowing from the conductor has to find its path through commutator segments, again through brushes to the external load. So, they collect the current from the armature windings. Is it clear?
Thank you. Now you connect Chanchandra. Yes, mute your mic. Now Chanchandra, please unmute your mic and give your feedback or allow your students to ask some questions.
GPT Chanchandra.
Hello.
Next GPT ಇನ್ನೊಂದಿದೆ ಕೇರ್ಪೇಟೆ ಆಯ್ತಾ ಕೇರ್ಪೇಟೆ
ಆಗಿದೆಯಾ
ಕೇರ್ಪೇಟೆ GPT ಕೇರ್ಪೇಟೆ ಇಲ್ವಾ ನೆಕ್ಸ್ಟ್ ಬೇರೆ ಯಾರು ಇದ್ದಾರೆ ಓಕೆ ರಾಮನಗರ GPT ರಾಮನಗರ ಅವರು ಯಾರು ಇದು ಎಲ್ಲ ಮೀಟ್ ಮಾಡ್ಕೊಂಡಿದ್ದಾರೆ ಅವರು
Ramnagara, please unmute your mic.
GPT Ramnagara.
Yes, please. Matadi, Ramnagara, matadi.
Unmute your video.
Video on madi.
Video on madi.
Video on madi.
Video on madi. Voice kelta ide. Matadi. Okay.
Matadi. Ramnagara, matadi.
GPT Ramnagara. Hello. Okay, okay. Okay. GPT next ಯಾರು ಇದ್ದಾರೆ? GPT ಚಂದ್ರಚಂದ್ರ ಇದ್ದಾರಾ? GPT ಚಂದ್ರಚಂದ್ರ, come online. ಅವ್ರು ಮೀಟ್ ಮಾಡ್ಬಿಡಿ. ರಾಮನಗರ. GPT ಚಂದ್ರಚಂದ್ರ. Hello.
Okay, now we request our DTE letters to all the participants. Now we request all the centers to mute your mic. Now our DT sir will say a few words. I'll address all the centers from his chamber. Now we are going to connect our DT sir. Sir.
Good afternoon. Hello.
Yes. Thank you, sir.
It was an excellent presentation by Aruna Madam, SJ Government Polytechnic.
Thank you.
At the outset, I would like to thank Aruna Madam and the Principal DVS, SJ Government Polytechnic.
Thank you, sir.
Given an excellent presentation on DC machines.
Thanks.
And today I saw some portion of it, and some principals, for example, Gulbarga, he is unable to speak. It is because he is using external mic. He should not use external mic. Better he should talk with laptop only. Then there is no problem at all. So instead of using external mic, you use laptop mic. Definitely there may not be any problem. So likewise, some other polytechnics, even Karwar Hegde speaking, but it was not so clear. There may be some problem with internet and all. He has to check. Otherwise, it is an excellent presentation. Just Patil has come from Gulbarga. Let him right now also he can speak with laptop mic. It is possible. We can hear and we can get the feedback from the principal. Otherwise, all the principals are cooperating and doing well. And Ramnagar principal is in the chamber only. He has not connected to classroom. It is not like that. He has to connect to the classroom and set up one classroom, smart class. Then regularly she should come on classroom session only, not in the chamber. So otherwise, the Abdul Kader has done a very good job today. It was an excellent because laptop as well as the LCD projector is also very good. So presentation, what he heard and what we heard from Abdul Kader from KPT Bangalore, it was excellent. So otherwise, everything is went on very well. So here afterwards, principals, all the polytechnic who have not submitted their request about shortage of faculty in which subject they have a shortage of faculty is not yet submitted by many of the principals. Now at least they should submit, so that we can start this presentation of the session in future, and we can reach to all the students who are there in the remote. And the main objective of this smart class, interactive smart class, is even after this class hours, Bijapur principal have asked it should be uploaded in YouTube. It is coming in the YouTube. I think he has not gone through all the information. Suppose if you don't have YouTube and you don't know anything about how to open, how to do all those things, you need not worry. Simply you go to our DT website, dt.ker.nic.in. There, first line itself, DT Studio. You simply click DT Studio, it will come directly. This live class will come. Even after this class hours also, they can see all the students at any time, wherever they are in the classroom, they are outside the classroom, or evening, morning, whatever time they want. They can simply click our DT channel, go to DT website and click, then you get this class, so that you can make use of this opportunity, whatever is coming to you, and you should be a better student, and you should be useful for our state and nation. That was our intention. Once again, thank the Aruna Madam for giving very excellent presentation on dissemination, even though it is a very tough subject to understand from the student point of view, but she has made all the points very clear. and the students, even if they don't not understand any of the points, they can repeatedly, they can see it, and any doubts are there, let them ask through mail or through video chat, and madam will answer, I think. Thank you. Thank you.
Thank you very much.
Thank you.
And we thank all the principals. Thank you, sir. We thank all the principals for participating in this video conferencing. And now I request them to mute their mic and log off. Thank you, sir.
Naik,
sir.
Naik.
Yes, sir.
You connect to Patil Gulbarga with laptop mic.
Pardon, sir?
You connect to Gulbarga laptop mic. Let him use the laptop mic.
Okay.
About the program.
Okay. We request Patil from Gulbarga online once again. Patil sir from Gulbarga.
Let him use laptop mic only.
Yes. Patil,
laptop,
use your laptop mic. Yes. Yes, Gulbarga, please.
Unmute Paniada.
Except Gulbarga, we request all other participants to unmute their mic. And Patil sir, you unmute your mic and you now speak. DT is online.
Right, sir. Thank you.
Patil, you sit down, please.
Patil, record matadi, sir.
You can sit down and talk. You use that mic and talk with the laptop mic only. You disconnect this, whatever you are handling now, you disconnect that, to talk directly using the laptop mic. There is a built-in mic in laptop. There is a built-in mic in laptop always. Use this, you use this external mic. Don't use this. Laptop, in front of laptop you speak. You need not worry about that. You sit down there only, you can talk. ಬರ್ತದೆ ಅಲ್ಲಿಂದ ನೀವು ಏನು ಮಾಹಿತಿ ಹುಡುಕಕ್ಕೆ ಹೋಗ್ಬೇಡಿ, ಆಟೋಮೆಟಿಕ್ ಇಟ್ ಇಸ್ ದೇರ್. ಮಾಹಿತಿ is there in laptop. ಸಲಹೆ ಕೂತ್ಕೊಂಡು ಮಾತಾಡಿ.
ನಮ್ಮ ಎಜುಕೇಶನ್ ರೂಮ್ ಅಲ್ಲಿ ಮಾಡಬೇಕು ಸರ್ ಇದನ್ನ. ಸರ್ ನಮ್ಮ ಎಜುಕೇಶನ್ ರೂಮ್ ಅಲ್ಲೇ ಸೆಕ್ಷನ್ ಕನೆಕ್ಟ್ ಮಾಡಿಬಿಟ್ಟು ಮಾತಾಡಬೇಕು ಸರ್. ನೆಕ್ಸ್ಟ್ ಕ್ಲಾಸ್ ಅಲ್ಲಿ ನಾವು ಲ್ಯಾಪ್ಟಾಪ್ ಜೊತೆಗೆ ಕನೆಕ್ಷನ್ ಮಾಡ್ಕೊಂಡ್ಬಿಟ್ಟು ಮಾತಾಡಬೇಕು ಸರ್. ನೆಕ್ಸ್ಟ್ ಕ್ಲಾಸ್
ನಿಮ್ಮ ಹತ್ರ ಲ್ಯಾಪ್ಟಾಪ್ ಇಲ್ವಾ?
ಲ್ಯಾಪ್ಟಾಪ್ ಇದೆ ಸರ್.
ನೀವು ಇಲ್ಲೇ ಕೂತ್ಕೊಂಡು ಬಿಟ್ಬಿಡಿ, ಇದನ್ನ ಡಿಸ್ಕನೆಕ್ಟ್ ಮಾಡಿ, ಆಫ್ ಮಾಡಿ, ಹಂಗೆ ಮಾತಾಡಿ, ಕೇಳಿಸುತ್ತೆ. ನೀವು ಮಾತಾಡಿ ಆಗತ್ತೆ, ಸೈಡ್ ಹಾಕ್ಬಿಡಿ, ಇದೇನು ಬೇಕಾಗಿಲ್ಲ. Now I am speaking with my laptop. Now I am speaking with laptop only. That is only iPad, even it is not a laptop. I am talking to you with using only iPad, even it is not laptop at all.
Mobile data. Mobile ಜೊತೆಗೆ ಕನ್ವರ್ಸೇಷನ್ ಮಾಡಬಹುದು.
ಮೊಬೈಲ್ ಏನ್ ಬೇಡ, ಮೊಬೈಲ್ ಬೇಡ. ಲ್ಯಾಪ್ಟಾಪ್ ಈಗ ನೀವು ಕಾಣಿಸ್ತಾ ಇದ್ದೀರಿ ಅಂದ್ರೆ ನಿಮ್ಗೆ ಕೇಳಿಸ್ತಾ ಇದೆ, ನಮ್ಗೆ ಏನ್ ಬೇಡ, ನೀವು ಹಾಗೆ ಮಾತಾಡಿದ್ರೆ. ಎಸ್
ಸ್ಕ್ರೀನ್ ಮೇಲೆ ಈಗ ಇದು ಡಿಸ್ಪ್ಲೇ ಮಾಡಿ ಕೊಟ್ಟಿದ್ದು
ನಿಮ್ಗೆ ಅರ್ಥ ಆಗಿಲ್ಲ, ನಾವು ಮಾತಾಡಿದ್ದೆ ಅರ್ಥ ಆಗಿಲ್ಲ. ಈ ಕಾಲ್ ಮಿ ವಿತ್ ಯೂಸಿಂಗ್ ಯುವರ್ ಫೋನ್, ಐ ಕ್ಯಾನ್ ಯು ಕಾಲ್ ಮಿ. ಮೈಕ್ ಯೂಸ್ ಮಾಡಿದ್ರೆ ವಾಯ್ಸ್ ಕ್ಲಿಯರ್ ಇರೋದಿಲ್ಲ.
ಡಿಸ್ಕನೆಕ್ಟ್ ಮಾಡಿ, ಎಕ್ಸ್ಟರ್ನಲ್ ಮೈಕ್ ಆಕ್ಟಿವೇಟ್ ಆಗುತ್ತೆ.
ನೀವು ಆ ಮೈಕ್ ಯೂಸ್ ಮಾಡಿದ್ರೆ ವಾಯ್ಸ್ ಕ್ಲಿಯರ್ ಇರೋದಿಲ್ಲ.
ಮೈಕ್ ಅಂತ ತೆಗೆದುಬಿಟ್ಟು ಡಿಸ್ಕನೆಕ್ಟ್ ಮಾಡಿ ಸರ್, ತೆಗೆದುಬಿಡಿ ಅಲ್ಲಿಂದ.
ನೀವು ಹಂಗೆ ಮಾತಾಡಿ ಸಾಕು, ಏನ್ ಬೇಡ, ಅಲ್ಲಿ ಕುತ್ಕೊಂಡು ಮಾತಾಡಿ ಸುಮ್ಮನೆ.
ಅದು
ಹಲೋ
ಮಾತಾಡೋದು ನಮ್ಗೆ ಕೇಳಿಸ್ತಾ ಇದೆ.
ಅಲ್ಲ ಬಿಲ್ಟಿನ್ ಮೈಕ್ ಯೂಸ್ ಮಾಡೋದಿಲ್ಲ, ಆಟೋಮೆಟಿಕಲಿ
ಡಿಸ್ಕನೆಕ್ಟ್ ಮಾಡೋದು. ಓಕೆ, ಎಕ್ಸ್ಟರ್ನಲ್ ಮೈಕ್ ಡಿಸ್ಕನೆಕ್ಟ್ ಮಾಡೋದು. ಆಯ್ತು, ಓಕೆ.
ರಿಜೆಕ್ಟ್ ಮಾಡಿ ಆಟೋಮೆಟಿಕ್ ಬಿಲ್ಟಿನ್ ಮೈಕ್ ಎನೇಬಲ್ ಆಗುತ್ತೆ.
ಬಿಲ್ಟಿನ್ ಮೈಕ್ ಯೂಸ್ ಮಾಡಿ ಮಾತಾಡಿ
ಸರ್. ಎಕ್ಸ್ಟರ್ನಲ್ ಮೈಕ್ ಡಿಸ್ಕನೆಕ್ಟ್ ಮಾಡ್ಬಿಡಿ, ಬಿಲ್ಟಿನ್ ಮೈಕ್ ಆಟೋಮೆಟಿಕ್ ಎನೇಬಲ್ ಆಗುತ್ತೆ. ಲ್ಯಾಪ್ಟಾಪ್ ಅಲ್ಲಿ ಮಾತಾಡಿ ಸರ್. ಈಗ ಇಲ್ಲ, ದೂರ ನಿಂತ್ಕೊಂಡು ಮಾತಾಡಿ, ಆರಾಮಾಗಿ
ಸರ್.
ಲ್ಯಾಪ್ಟಾಪ್ ಅಲ್ಲಿ ಮಾತಾಡಿ ಸರ್.
ಗುಲ್ಬರ್ಗ, ಮಂಗಳೂರು ಎಲ್ಲ ಆಲ್ ರಿಮೋಟ್ ಪ್ಲೇಸಸ್
ಲ್ಯಾಪ್ಟಾಪ್ ಹತ್ರ ಮಾತಾಡಿ.
ಹುಡುಗರು ಇಲ್ಲಿ ಕೂತ್ಕೊಂಡೆ ಏನ್ ಬೇಕು
ಪಾಟೀಲ್ ಸರ್. ಸರ್ ಪಾಟೀಲ್ ಸರ್ ಸೌಂಡ್ ಬರ್ತಾ ಇದೆ, ಮಾತಾಡಿ.
ಹಲೋ,
ಯಾಕಂದ್ರೆ ಎರಡು ಕ್ಲಾಸ್ ಯಾವ ಕಾಲೇಜ್ ಬೇಕಾದ್ರೆ ಎಲ್ಲ ನೀವು ನಿಮ್ಮ ಮೊಬೈಲ್ ಅಲ್ಲಿ
ಮಾತಾಡಿ ಸರ್, ಕೇಳ್ತಾ ಇದೆ.
ಅಲ್ಲೇ ಒಂದು ಲ್ಯಾಪ್ಟಾಪ್ ಇದೆ, ಲ್ಯಾಪ್ಟಾಪ್
ಬಟ್ ಇದು ಈ ಲ್ಯಾಪ್ಟಾಪ್ ಕೇಳ್ತಾ ಇದೆ ಸರ್.
ಲ್ಯಾಪ್ಟಾಪ್ ಎದುರುಗಡೆ ಕೂತು ಮಾತಾಡಿ ಸರ್.
ಹಲೋ ಸರ್.
ಹಾ ಹೇಳಿ ಸರ್.
ಮಾತಾಡಿ ಪಾಟೀಲ್.
ಹಲೋ
ಹಲೋ
ಹಲೋ ಸರ್.
ಹಾ ಮಾತಾಡಿ ಪಾಟೀಲ್.
ಹಾ ಸರ್, ಕೇಳ್ತಾ ಇದೆ ಸರ್. ಹಲೋ ಸರ್.
ಓಕೆ
ಸರ್. ಹಾ ಸರ್, ಕೇಳ್ತಾ ಇದೆ ಸರ್, ಮಾತಾಡ್ತೀನಿ ಸರ್.
ನಾಯಕ್ರೆ
ಅಲ್ಲೇ ಮಾತಾಡಿ ಸರ್. ಸರ್ ಕೇಳ್ತಾ ಇದೆ ಸರ್, ಮಾತಾಡ್ತಾ ಇದ್ದೇನೆ ಸರ್.
ಪಾಟೀಲ್ ನಿಮ್ ಮಾತು ನಮಗೆ ಕೇಳಿಸ್ತಾ ಇದೆ. ಪಾಟೀಲ್ ಅವರೇ ಸುಮ್ಮನೆ ಮಾತಾಡಿ ನೀವು. ಆರಾಮ್ ಮಾತಾಡ್ರಿ ನೀವು. ನಿಮ್ ಮಾತು, ನಿಮ್ಮದು ವಾಯ್ಸ್ ನಮಗೆ ಕೇಳಿಸ್ತಾ ಇದೆ.
ಹಾ ರೈಟ್ ರೈಟ್ ಸರ್. ಓಕೆ ಓಕೆ ಸರ್. ಕ್ಲಾಸ್ ಈಗ ಇದು ಇಲ್ಲ ನಮ್ಮಲ್ಲಿ ಹುಡುಗರು ಒಂದು 30-40 ಹುಡುಗರು ಬಂದಾರ ಸರ್ ಇಲ್ಲಿ.
ಎಷ್ಟು ಚೆನ್ನಾಗಿ ಕೇಳಿಸ್ತಾ ಇದೆ ನೋಡಿ ಸರ್. ಓಕೆ ಓಕೆ ಸರ್, ಮಾತಾಡಿ ಸರ್. ಕೇಳಿಸ್ತಾ ಇದೆ ಸರ್, ಮಾತಾಡಿ.
ಹಾ ಕೇಳ್ತಾ ಇದೆ ಸರ್. ಬಂದು 40 ಹುಡುಗರು ಬಂದಾರ ಸರ್ ಈಗ. ಇಲ್ಲಿ 3rd ಸೆಮಿಸ್ಟರ್ ಎಲೆಕ್ಟ್ರಿಕಲ್ ಹುಡುಗರು. ಇಲ್ಲಿ ನಾವು ಅಡ್ಮಿಷನ್ ಹಾಲ್ದಲ್ಲಿ ಇಲ್ಲಿ ಡಿಸ್ಪ್ಲೇದಲ್ಲಿ ಎಲ್ಲ ಇದು ಹುಡುಗರು ತಾವು ಹೇಳ್ತಾ ಇರೋದು
ಸರಿ
ಎಲ್ಲ ಕೇಳಿಸ್ಕೊಂತ ಇದ್ದಾರೆ ಸರ್.
ಓಕೆ,
ಚೆನ್ನಾಗಿತ್ತು ಸೆಷನ್. ಸೊ ಇದೇ ತರ ತಾವು ಕಂಟಿನ್ಯೂ ಮಾಡ್ಬೇಕಂತ ತಮ್ಮಲ್ಲಿ ನಾನು ರಿಕ್ವೆಸ್ಟ್ ಮಾಡ್ತಾ ಇದ್ದೇನೆ ಸರ್. ಸರ್ ಹುಡುಗರು ಏನಾದ್ರು ಡೌಟ್ಸ್ ಇದ್ರೆ ಇಂಟ್ರಾಕ್ಷನ್ ಮಾಡ್ಬೇಕಾದ್ರೆ ಸ್ವಲ್ಪ ಇದು
ಮಾತಾಡ್ತಾ ಇದ್ದೀರಲ್ಲ ಸರ್, ಅಲ್ಲಿಂದ ಹುಡುಗರ ಹತ್ರ ಪ್ರಶ್ನೆ ಕೇಳಿಸ್ರಿ, ಈಗಲೇ ಉತ್ತರ ಕೊಡ್ತಾರೆ ಮೇಡಮ್ ಅವರು.
ಸ್ವಲ್ಪ ಯಾರಾದ್ರೂ ಏನಾದ್ರು ಡೌಟ್ಸ್ ಇದ್ರೆ ಇಲ್ಲಿ ಬಂದು ಮಾತಾಡ್ತೀವಿ. ಏನಾದ್ರು ಒಂದು ಯಾರಾದ್ರೂ ಈಗ ಇದುವರೆಗೆ ಸೆಷನ್ ಆಯ್ತಲ್ಲ, ಜಲ್ದಿ ಬರ್ರಿ.
ಮಾನಿಟರ್ ಬಹಳ ಮೂವ್ ಆಗ್ತಾ ಇದೆ, ಅದನ್ನ ಸ್ಟಿಲ್ ಮಾಡಿ ಸರ್. ಮಾನಿಟರ್ ಅನ್ನ ಅಂದ್ರೆ ನೀವು ಮೊಬೈಲ್ ಹಿಡ್ಕೊಂಡು ಮಾಡ್ತಾ ಇದೀರಿ ಅಂತ ಕಾಣಿಸ್ತದೆ. ಮೊಬೈಲ್ ಅಲ್ಲಿ ಲಾಗಿನ್ ಆಗಿರ್ಬೇಕು ನೀವು. ಮೂವ್ ಆಗ್ತದೆ, ಒಂದೇ ಕಡೆ ಸ್ಟಿಲ್ ಮಾಡಿ ಹಿಡ್ಕೊಂಡಿರ್ರಿ. ಆಮೇಲೆ ಅದು ಟಿಲ್ಟ್ ಮಾಡ್ರಿ, ಸ್ವಲ್ಪ ಕ್ರಾಸ್ ಆಗಿದೆ. ಎಸ್ 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 ಈ ತರ. ಹಾ, ಅಷ್ಟಿಗೆ ನಿಲ್ಸ್ಕೊಳ್ಳಿ ಸರ್. ನೀವು ನಿಮ್ಮ ಮುಖ ನೋಡ್ಕೊಳ್ತಾ ಇರಿ ಸರ್ ನಿಮ್ ಸ್ಕ್ರೀನ್ ಅಲ್ಲಿ ಎಲ್ಲಿ ಕರೆಕ್ಟ್ ಬರ್ತದೆ ಆವಾಗ ಅದನ್ನು ಸ್ಟಿಲ್ ಮಾಡಿ. ಸರ್ ನೀವು ಕವರ್ ಆಗ್ಲಿಲ್ಲ.
ಗುಲ್ಬರ್ಗ ಅವ್ರದ್ದು ಏನೋ ಡಿಫಿಕಲ್ಟಿ.
ಏನಿಲ್ಲ ಸರ್, ಅವರು ಮೊಬೈಲ್ ಯೂಸ್ ಮಾಡ್ತಾ ಇದ್ದಾರೆ ಸರ್, ದಟ್ ಇಸ್ ಪ್ರಾಬ್ಲಮ್. ಅಂದ್ರೆ ಅದು ಕೈಲಿ ಹಿಡ್ಕೊಂಡಿದ್ದಾರೆ, ಅದು ಮೂವ್ ಆಗ್ತಾ ಇರ್ತದೆ.
ಮೊಬೈಲ್
ಎಸ್ ಎಸ್ ಎಸ್
ಮೊಬೈಲ್ ಯೂಸ್ ಮಾಡ್ತಾ ಇಲ್ಲಿರ್ತೀವಲ್ಲ ಸರ್, ಮೂವ್ ಅಲ್ಲ ಸರ್.
ಈಗ ಕರೆಕ್ಟ್ ಇದೆ ಸರ್, ಹಾಗೆ ನಿಲ್ಸಿ ಸರ್, ಕ್ಯಾಮ್ರಾ ಮೂವ್ ಮಾಡಬೇಡಿ. ಓಕೆ ಸರ್, ಅಷ್ಟೇ ನಿಲ್ಸ್ಕೊಳ್ಳಿ ಸರ್. ಪಾಟೀಲ್ ಸರ್
ಓಕೆ ಮೂವ್ ಮಾಡಂಗ.
ಎಸ್ ಸರ್. ಸರ್ ಹೇಳಿ ಈಗ ಪಾಟೀಲ್ ಸರ್, ಈಗ ನಿಮ್ಮ ಸ್ಟೂಡೆಂಟ್ಸ್ ಏನಾದ್ರು ಈಗ ಕರೆಕ್ಟ್ ಇದೆ ಸರ್, ಕ್ಯಾಮ್ರಾ ಹಾಗೆ ಇರ್ಲಿ. ಪಾಟೀಲ್ ಸರ್
ಸರ್ ಹೇಳಿ.
ಈಗ ನಿಮ್ ಸ್ಟೂಡೆಂಟ್ಸ್ ಏನಾದ್ರು ಪ್ರಶ್ನೆ ಕೇಳೋದಿದ್ರೆ ಕೇಳಿಸಿ ಸರ್. ಇದಾರಾ?
ಧಾರಾವಾಹಿ ಕೇಳ್ರಿ ಬಂದು ಸರ್. ಯಾರು ಏನೋ ಡೌಟ್ಸ್ ಇಲ್ಲ ಅಂತ ಹೇಳಿದ್ರೆ ಸರ್.
ಓಕೆ, ಥ್ಯಾಂಕ್ ಯು ಸರ್. ಸರ್ ಡಿ ಟಿ ಸರ್, ನೀವು ಡಿ ಟಿ ಸರ್ ಹೇಳಿ ಸರ್.
ಓಕೆ, ಥ್ಯಾಂಕ್ ಯು. ಈಗ ಏನಾದ್ರು ಸಮಸ್ಯೆ ಇದ್ದಾರೆ ಅವ್ರು ಕ್ಲಿಯರ್ ಮಾಡ್ಕೋಬೇಕು.
ಅದೇ ಅದೇ ಅದೇ.
Everyone has to go to DT website and they can click to DT channels and they will get this video class. Any number of times they can repeat.
Yes. ಈಗ 2 days ಅಲ್ಲಿ more than 1000 viewers ಆಗಿದ್ದಾರೆ ಸರ್, ಯೂಟ್ಯೂಬ್ ನಲ್ಲಿ ನೋಡಿದ್ದೆ.
ಓಕೆ, ವೆರಿ ಗುಡ್.
ಎಸ್, ಅದೇ ತರ ಅವರು ಈಗ DT ವೆಬ್ಸೈಟ್ ಅಲ್ಲಿ ನೋಡಿದ್ರೆ ಇನ್ನು ಈಸಿ ಆಗ್ಬಿಡ್ತದೆ, ಅವ್ರಿಗೆ ಈಸಿ ಅಕ್ಸೆಸಿಬಲ್.
ಈಗ ಅದಕ್ಕೆ ನಾನು ಇನ್ನು ಅವರಿಗೆಲ್ಲ DT ಅಡ್ರೆಸ್ ಇದನ್ನ ಕೊಟ್ಬಿಡಿ, DT ವೆಬ್ಸೈಟ್
ಅದು ಎಲ್ಲ
dt.nic.in.
Yes, all principals should educate their students to go to DT website.
DT,
yes sir.
Simply let them go to DT website and click DT channel.
Yes sir, yes sir, yes sir, yes sir.
They will not bother anything.
Okay sir, thank you sir. ಹಾಗಿದ್ರೆ ಕ್ಲೋಸ್ ಮಾಡ್ತೇವೆ ಸರ್ ಇವತ್ತು ವಿಡಿಯೋ.
Okay, thank you.
Okay sir, thank you very much. Thank you all the principal.
Thank you very much.
Please, yes, log off. I request you to log off. Thank you sir.
Next one, my guy.